Okay, so here's an illustration in your textbook of how to work Bayes' theorem. Now, just a couple things. Bayes' theorem is basically conditional probability using what they call the multiplication law for dependent events. And typically the way I like to set these up is I'm going to write this right here. This is going to be at number 35 is what we're going to work. And so I call this the tabular approach. So we're going to set these up as the first box, we're going to call it the prior probability. Then we're going to have what is said to be the conditional probability. Set that as another column, okay? And then I'm going to write joint probability as another heading. And then the last column, I'm going to call that your posterior probability. All right, now, in addition to that, I'm going to go ahead and give you some more labels. I want you to write a couple things here. For the prior probability, I want you to think of that as the margin. And of course, you got the condition and the joint. And so I'm going to label typically the first column as AI. I'm going to label the second column as event B given AI. I'm going to write the third column as what I call your joint or your intersection. And then I'm going to show you how to get to the posterior. But the basic idea is if you go back and look at the multiplication law for two dependent events, to get this joint probability, you're going to take the margin multiplied by the condition is going to give you that joint. And just remember that the sum of your margins must equal 1.00. So if I look at this problem, it says the Ludlow Wildcats baseball team, a minor league team in the Cleveland Indians organization, plays 70% of their games at night and 30% during the day. So I can say let's let A1 represent the night games, and I'm going to say let's let A2 represent the day games. And you notice in this column, if I put this in this column as A1 and A2, these two will add up to 1. Those are your margins. So 70% of games are at night. I'm going to put 0.70. And then for the day games, I'm going to put 0.30. And notice that adds up to 1. So that's how you recognize what they call your prior probabilities. It's basically your margins, like from your contingency, contingency tables, and they should always add up to 1. Now, this event B, if you keep reading, that's going to be the event of, I'm going to put this over here, B is if you win the game. We're going to label that event as winning. And they tell you that the team wins 50% of their night games. I'm going to put that right there as 0.50. And it says they win 90% of their day games. I'm going to put that right there as 0.90. So notice that this 50% goes with the night games, and this 0.90 goes with the day games. So once you've got that filled out, the next step is simply to multiply. And I think you're going to find that as you do Bayes' theorem, or Bayes' theory types of problems, and you set it up in this tabular approach, typically once you get the first two columns, that's most of the work. That's going to be the hardest part. Once you get that, everything else you're going to see in a moment is actually not too bad. So if you take 0.7 and you multiply that by 0.5, you get 0.35. I'm going to put that right here as 0.35. Again, that's just taking 0.70 times 0.50. Now, if I take 0.30 and multiply that by 0.90, that's going to give me 0.27, and I'm going to put that right there. Okay, again, that refers to your intersection or your joints. Now, at this point, what Bayes' theory kicks in, it says you want to add up your joints. So if you take 0.35 and add 0.27, you're going to get 0.62. So I'm going to put that right here as 0.62. That's basically the sum of your joints. And then the very last step, then the posterior, which sometimes they refer to as the updated probability, you simply take 0.35, divide by 0.62, and you take 0.27 and divide that also by 0.62. And you can typically just take these out 2 decimals. So if you take 0.35 and divide by 0.62, you're going to get approximately, I'm just going to round this off, you're going to get approximately 0.56. And then if you take 0.27 and divide that by 0.62, you're going to get about 0.44. I'm going to write that right there. Again, I rounded these off to 2 decimals, but again, you could also show that those also add up to 1. Now, one more label here. I didn't put this at the beginning. Once you get to this step in the Bayes' theorem process, I like to label this last column as the probability of A given B. because that's basically the way this thing works. You start off with the prior, you apply a condition, you get the joint, and then you kind of rework it by taking the individual joints divided by the sum of the joints to get the posterior, and then somehow this column just becomes A given B. So the way you want to read it like this, once you got the posteriors, you could say given B, if they won the game, you could say there's a 56% chance they played, looks like this case, at night, and there's a 44% chance they played at the day. So the question up here says, what is the probability of the game? So it says, I'm sorry, according to today's newspaper, they won. So guess what? That's given. Given B, given they won, what is the probability the game was played at night? And you could basically say the answer to that, go right here, is 0.56. And again, this is Bayes' theorem.